2018, but could reflect what is the situation in the actuality. For example, in Spain and India, we have at the clinical field between 25 to 50% of Staph aureus that are methicillin-resistant. And the problem of this kind of resistance is that the strain produce a modified penicillin-binding protein. It's the protein to which the antibiotic bind, and the altered protein have no affinity for beta-lactam, so the bacteria is resistant to most of beta-lactam except new cephalosporin, but most of the beta-lactam are inactive in methicillin-resistant Staph aureus, and in addition, many of these strains are also resistant to other antibiotics. So methicillin-resistant Staph aureus is a real problem at clinical field. If we analyze the epidemiology of methicillin-resistant Staph aureus, we know that it was a very important, it was and it is at the present moment an important problem in the healthcare system, and we can identify an entity that is the hospital-acquired MRSA. There are a specific lineage of methicillin-resistant Staph aureus implicated in hospital-associated MRSA. In the 90s of the last century, it appeared community-acquired methicillin-resistant Staph aureus that it was spreading in healthy humans that have a specific characteristic and is associated to a specific lineage. And in 2005, it appeared a new epidemiological entity that it was the livestock-associated methicillin-resistant Staph aureus, mostly associated to pigs, and it was the lineage CC398. But I am not going to talk about this lineage, but to the new mechanism that it was described for the first time in 2011, that is the MRSA mechanism in methicillin-resistant Staph aureus. Going back to the history, this new MRSA mechanism was described for the first time in 2011, and it was in a sample of milk implicated in bovine mastitis. It was an isolate recovered in 2007 that they realized that it contained a different mechanism of resistance, different to the MRSA, that is the normal mechanism of resistance of methicillin resistance. So in this study, in which the first MRSA isolate was discovered, they also recovered isolate from UK and Denmark, coming from human cows and milk with the similar mechanism of resistance. And they realized that the first isolate with this mechanism of resistance was back to 1975, but it was characterized in 2011. The characteristic of this new mechanism is that the MRSA is integrated in a new SCC-MEC, that is the system that contains the MEC mechanism, that is the SCC-MEC11, that in addition to the MEC, the new MEC, they contain a gene specific for resistance to penicillin, a gene encoding beta-lactamase, and interestingly, it contains also an operon implicated in arsenic resistance. This new system is specific of MRSA and have never been described in the usual mechanism that is MRSA. This new C mechanism has an identity at DNA level of 69% and at amino acid level of 63%. This is the MRSA that is different to the MRSA, that is the most frequent mechanism. and also different to the MECP that was previously reported in Macrococcus caseolithicus. So we are going to focus our attention in this MEC-C that is different to MEC-A but have some homology. And what is interesting about this new mechanism of resistance? It codifies for a new PBP2 that instead of PBP2A is named PBP2C that have a higher affinity for oxacillin than for cefoxitin. And this is very important because cefoxitin is a better predictor of methicillin resistance than oxacillin. And this is very important in the microbiology lab because for broad and agar dilution method, we usually utilize oxacillin to detect methicillin resistance. So the methicillin-resistant Staph aureus of this specific mechanism frequently appear as cefoxitin-resistant and oxacillin susceptible. So considering this, it can be misleading in the usual laboratory technique that use oxacillin for broad and agar dilution method. So it has a very important practical implication that we should be aware that if we find a methicillin-resistant Staph aureus that is resistant to cefoxitin but susceptible to oxacillin, we should think in this specific mechanism of resistance. The PBP2C has another important characteristic, is that is thermosensible. It means that the activity is different depending on the temperature. And most of methicillin-resistant Staph aureus, MEC-C positive, are susceptible to non-beta-lactam agent. This is another important characteristic of this mechanism. And there is another point that we have to analyze in relation with this mechanism, and mostly with the SCC-MEC11, in which the MEC-C is integrated. I already have indicated that in addition to the new MEC, it has a BLA-CETA gene that encodes in beta-lactamase. One important point is that MEC-C do not confer penicillin resistance. The penicillin resistance is mediated by the beta-lactamase gene, the BLA-CETA gene, that is integrated in the same structure. So in vitro and in vivo experimental model indicate that if we add penicillin and clavulanic acid, the clavulanic acid inhibit the beta-lactamase, so the strain that contain this specific mechanism of resistance theoretically could be treated by penicillin plus clavulanic acid differently to the MEC-A classical methicillin-resistant Staph aureus. This has a very important clinical and therapeutical implication. We could have another option in this type of mechanism of resistance in relation with the MEC-A type. And which genetic lineage we can find in methicillin-resistant Staph aureus MEC-C? Most of the isolates correspond to the clonal complex 130, although other clonal complexes as 425 or 1943 can be also detected in addition to other. But the most frequent one is CC130. So if we detect this specific lineage in a methicillin-resistant Staph aureus, we should look because it is possible that contain the MEC-C mechanism. So which phenotypic and genotypic marker we can detect in MEC-C methicillin-resistant Staph aureus? At the phenotypic level, the FOXR OXA susceptible is a marker, and the susceptibility to non-beta-lactam agent is another specific marker of this this type of resistance. And at genotypic level, specific S-type and clonal complexes that are associated to this mechanism, as is the case of CC130, and also the presence of a specific virulent gene that is only detected, as we are going to indicate, is only detected in isolate of this specific lineage associated to MRSA. So this is another genotypic marker to detect this specific resistant isolate. Most of the isolate are negative for the gene SCN, that is a phenotypic marker of a host of human adaptation. I will talk about that later. So we are going to see which is the epidemiology and the prevalence of this specific methicillin-resistant Staph aureus MRSA in different ecosystems. And we can say that MRSA MRSA have been detected in many different types of ecosystems, mostly in Europe, since the 2011 in which it was described. A lot of publication has appeared describing methicillin-resistant Staph aureus MRSA in Europe, corresponding to different genetic lineage. Outside Europe, it has also detected in animal, mostly in livestock, but not only in livestock, and in humans, in different countries of Asia, Africa, or America, but most of the description so far are still in Europe. And to my knowledge, no reported so far in India, but we have to be aware that this mechanism could be misleading because oxacillin is sometimes it could appear as susceptible, so people can think that it's a methicillin susceptible instead of methicillin resistant. So we have to be aware of that. What is the situation of MRSA MRSA in livestock? I have performed a revision of which are the whole report related with MRSA MRSA in livestock, and we can see that dairy cows are the most frequent livestock associated to MRSA MRSA. We see in Germany to 28%, in France 22%, in Brazil 26%, or in Malaysia 16% of isolate correspond to this, of methicillin-resistant Staph aureus correspond to this specific lineage. But also there are studies related with pigs with also very high prevalence, but mostly dairy cows is the most frequent livestock associated with methicillin-resistant Staph aureus of this specific lineage. What about humans? I have indicated that the first isolate detected in human with this mechanism of resistance was in Denmark, in isolate that a blood isolate recovered in 1975. And in Denmark, they have tracked the evolution of this specific mechanism. In 2010, 1.9% of the Staph aureus corresponded to this specific mechanism, and in 2011 it increased, so it seems to be increasing. But there are other countries in which the prevalence is low. If we analyze the prevalence in different countries, we see in green correspond to very low prevalence, less than 1% in many European countries. So it is described in clinical hospital, but in a low prevalence. But there are countries in which the prevalence can be from 1 to 3 or even up to 8% in a study in Slovenia or 3% in Pakistan. So the prevalence in human, in hospital is still low, but we have to be aware that can be misidentified because the specific characteristic. And the specific lineage of the human isolate, you can see in the different countries that have been described that correspond in most of the cases to the clonal complex 130, 425, or 1943. We performed a review of the characteristic of the MRSA strain in human patients. It was a review performed in 2020 by our group, and we detected that most of the isolate that have been described in the literature corresponded to skin and soft tissue infection that represents 61% of total isolate, blood isolate 6%, and also epidemiological control isolate in 23%. So skin and soft tissue infection is the most relevant type of pathology of the patient that have this type of isolate. But we try to review if there were cases of zoonotic transmission. In the literature, we have detected 3 cases, 3 publications in which zoonotic transmission of MRSA have been described. One of them, the last one, reported by our group. The 2 first ones were performed in Denmark, associated either with cows, either with sheep, or with pigs, in which there was after analysis by genomic analysis, they could consider that there were zoonotic transmission. We also analyzed a case of a potential zoonotic transmission because it was a farmer in which an skin and soft tissue infection was detected in a farmer that has a close correlation with animal, and with after the analysis we determined this potential zoonotic transmission. And what about wildlife? This specific mechanism of resistance is in wildlife is the next question we can address. And in wildlife, the prevalence of this type of isolate, of this type of methicillin-resistant Staph aureus is very well reported. There are most of the studies in wildlife have been performed in Europe, and it has been reported in many different animals, wildlife animals, but there are some of them that are especially relevant, as is the case of hedgehog, as I will tell you later, but also rabbits and rear deer. So many different animal species have been tested or have been assumed that could be a reservoir of this specific methicillin-resistant Staph aureus with the genotype MEXI. In this table, you can see all publications related with wildlife in which methicillin-resistant Staph aureus MEXI have been detected. I highlight hedgehog that mostly in countries of Northern Europe they are colonized very frequently with this type of methicillin-resistant Staph aureus, with prevalences, as you can see, very, very, very high. Also, there are studies with red deer, wild rabbit, with different prevalences, but hedgehog are a very important reservoir of methicillin-resistant MEXI, mostly in northern countries. And in this sense, there are different studies performed by different groups in Denmark and Sweden that report prevalences in hedgehog higher than 60%, although this type of wild animal in other countries, the prevalence is lower. So it seems that the prevalence is different depending on the country in which these animals are included, and perhaps this author have very recently published a very nice paper in which they propose why this hedgehog could be colonized by MRSA. In this paper that was published last year in Nature, this group of people, of researchers, indicate that this type of wild animal, hedgehog, are colonized by a dermatophyte that is producing different beta-lactam antibiotic, and this could constitute a natural selective environment in which methicillin-resistant Staph aureus isolate could have an advantage to be maintained and colonizing this specific animal. This is a nice paper in which it can be established a correlation between the selective pressure of other microorganisms that could colonize hedgehog that could produce antibiotic that could select with this specific methicillin-resistant Staph aureus. I indicate that wild rabbit is also an animal in which the prevalence could be also high. There are studies performed in our country that refer even 26% of prevalence of methicillin-resistant Staph aureus in wild rabbits. But it has been also detected in domestic or captive animal or in environment, in water, in Spain and in Portugal. But I would like to address now the attention to the research we are doing in our group, in the One Health UR, that is our group in the University of La Rioja, in which we have focused one of the lineage of the group dedicated to the analysis of the MRSA. And in this sense, we have analyzed different ecosystems, mostly wildlife ecosystem. We have analyzed an ecosystem in which they convive a small mammal, red deer, and some humans that are in contact with red deer. We have analyzed this ecosystem. We have analyzed white stork, wild bears of different type, wild rabbits, and also wild pigs. In this sense, the first study was performed in red deer. It corresponds to a semi-extensive farm that grow the red deer to populate natural park and game states. So we analyze in this semi-extensive farm with red deer if they were colonized by methicillin-resistant Staph aureus of the genotype MEXI. Our surprise is what 16% of red deer contain in nasal sample this specific mechanism of resistance, methicillin-resistant Staph aureus with the MEXI, with the genetic lineage that we knew that were spreading in other environment. This is important because these animals were used later to populate natural park or game state, so they could spread this mechanism of resistance to other areas. The second analysis is to analyze in the area close to the red deer, in the same ecosystem, the small mammal that lived in the same area as the red deer. In this case, 2% of the small mammal carry methicillin-resistant Staph aureus, the MEXI mechanism of the same lineage, and interestingly, they carried a marker that we consider that is a human marker. The humans that were in contact with this type of animal in the same area were negative. So we assume that a potential transference between livestock, different animals, could exist and has already been described by other authors that describe the transference of methicillin-resistant Staph aureus MEXI from wildlife to livestock. The second ecosystem we analyzed was the white stork. When we analyzed 4 colonies of white stork, that is a migratory bird that in Spain is very popular, that come from the north of Europe and arrive to Africa, to the north of the Maghrebian countries. And we analyzed 2 colonies of stork that were in national park or in natural areas, and 2 that were in close to landfill. And we detected in low prevalence, we detected MRSA MEXI in 2% of the animal tested. In this case, they did not carry the specific genetic marker of human adaptation. And other wild animals that we analyze cinereous vulture, magpie. 5% of this animal were carrier of methicillin-resistant Staph aureus, MEXI, while rabbit 8%, and wild pigs were, we did not detect this specific methicillin resistant in wild pigs. Interestingly, some of the strain obtained from cinereous vulture and magpie were carrier of the human adaptation marker. That is important, and from the evolutive point of view, could be interesting to be tracking. The next thing we did was to analyze by whole genome sequencing a collection of 18 strains of the clonal complex CC130, 5 of them methicillin susceptible, and 13 of them methicillin resistant, but of the same genetic lineage that normally is associated with the MEXI mechanism. This study was performed in collaboration with Professor Holm of the University of Cambridge, that it was the group in which the MEXI MRSA, the MEXI mechanism was described for the first time in 1911. Here we have the 18 isolates that we analyzed that came from different origins, different livestock, wildlife, human, rabbit, from different locations in Spain or even in Tunisia, and with different genetic lineage, either susceptible or resistant to methicillin, as I already indicated. After the analysis of the genome of these 18 isolates, we can see that 6 isolates carry the genetic marker of the human genetic marker. That is was very, very relevant because no other studies have reported the detection of human adaptation marker among methicillin-resistant Staph aureus of the MEXI origin. And some of the methicillin susceptible carry a specific marker that could be related to adaptation to ruminant. And all of them, except one that seems to be of another lineage, carry the specific virulent factor that, as I already indicated, could be a specific marker of this methicillin-resistant Staph aureus MEXI. I indicated that we have an human marker that is the system that the immune evasion cluster gene, the IEC cluster, is considered a human adaptation marker, and our isolate, some of our isolate carry the IEC type E that is related with human adaptation. I also have talked about the von Willebrand factor binding protein that is associated to ruminant adaptation, and that that have been detected mostly in the susceptible isolate. When we perform the phylogenetic tree of the 18 MRSA CC398 strain, we can see how they cluster. They cluster in a separate way, the methicillin susceptible, and in a different, the methicillin resistant. And here we have those that carry the human adaptation system that have been detected either in MACPI or in red deer. So here we have some of the isolate that cluster very close together in isolate recovered, for example, from store or from human. The unique study in which MRSA, MRSA with the human adaptation market have been described in the literature are all of them in the Iberian Peninsula, in Spain and in Portugal. In Spain are most of them from our group study, but also from another group, and also in free isolate from Portugal obtained from small mammals. So this is an important point because it's an adaptation market that by any reason is detected in some of the isolate that could give us some clues related to the evolution of this specific mechanism and genetic lineage. We know that MRSA could have homologue in other staphylococcal species in addition to Staph aureus. So it has been described in Staphylococcus aureus homologue to the MRSA, in Staphylococcus silosus, in Stephanopavicii, in Caprai, in Warneri. So it's seen that coagulase negative staphylococci could be a reservoir of MRSA homologue that could be also very important in the evolution of MRSA in Staphylococcus aureus. So just concluding, we can say that MRSA, methicillin-resistant Staph aureus, have a specific phenotypic and genotypic marker, as I have indicated. The susceptibility to oxacillin and resistant to cefoxitin is something very important from the microbiology bench of view when people are in the lab, just to detect this type of isolate, and susceptibility to no beta-lactam, mostly associated to the lineage CC 130, 425, and 9043. If we detect this lineage in a methicillin-resistant Staph aureus, we should think in MRSA because they have never been associated with MRSA. MRSA MRSA is mostly detected so far in Europe, but now there are cases in all continents, mostly detected in dairy cows and wildlife, and occasionally in human, mostly implicated in skin and soft tissue infection, but also in invasive infection. Most of MRSA MRSA lack of the IC human adaptation marker, but the detection of IC positive strain in different wildlife hosts is of relevance in evolutive analysis. In this specific point, we are going ahead to see the implication, and transference between different ecosystems have been demonstrated, human, livestock, and wildlife. So the One Health approach is needed to face the study of MRSA MRSA. And I only have to thank to all the group or the One Health or the group of the University of La Rioja in Spain that have contributed to many of the data that I have presented, but also to all the group with which we collaborate in this subject and in other that allow us to advance in the study of antimicrobial resistance from the One Health perspective. And is everything that I was trying to show you in relation with this specific mechanism of resistance that, even though at the human level is still not frequent, we have to be aware that probably we have to take care in order to avoid misleading with the of this type of resistance.
Thank you, Professor Carmen, for a nice talk and very informative. I think there's a lot of questions in mind after having your talk. So let me ask participants if anybody can have any question in your mind. Please raise your hand. I think if nobody's asking questions, then let me ask a few questions if you allow me. A couple of questions in my mind. The first is that because you talk about the MAC-C gene, I have worked on MAC-A gene, almost more than a decade ago in my lab, and we found certain MAC-A gene in the hand wash of hospital personnel. That was interesting. So, and the phenotype of the MRSA was very, very high MIC for methicillin. So my question based on that, do you find the difference in MAC C, B, and A in terms of like percent homology and structure of the three proteins, as well as the phenotype which comes out in terms of like MIC from clinical perspective?
Clinical perspective, they are very, very different, and they have, it's very important to detect, mostly because from the clinical point of view, they present important difference. The first difference is that the MEK, for example, confer resistance to all beta-lactam except the new cephalosporin, and is included penicillin. In this case, penicillin is not, MEC-C do not confer resistance to penicillin, but to cefoxitin and oxacillin, yes. But the resistance is due to a beta-lactamase, the BLASITA gene. It means that BLASITA gene can be inhibited by clavulanic acid. So there are other options, even as the group of Professor Holm in Cambridge indicate other options in relation with this strain. And another important, very important, is that MEC-C confer high level of resistance to cefoxitin and oxacillin. So we can detect by this with cefoxitin and also very well with oxacillin by MIC. In the case of MEC-C, very frequently appear oxacillin susceptible and cefoxitin resistant. So if we only perform MIC, we can say that the strain is methicillin susceptible, and we can give a wrong treatment because we can treat as a susceptible, methicillin susceptible, and it's not. It's methicillin resistant.
Thank you. Okay.
So we have to use cefoxitin is better predictor. It's better predictor of resistance.
Right. Okay. Carmen, my second question is regarding the clonal relatedness of MAC-C, as you talk about in one of the study. So is it in terms of like different ST type based on ST type, MLST? Or my related to the same question is that does any specific MLST type or ST type of MRSA with MAC-C is more virulent in terms of like infection? So can you correlate with the ST type, specific ST type linked with MAC-C, MRSA having more?
They are more virulent or less virulent, you say?
Right.
Any
report?
Normally, yeah. This strain have always the ATD2 virulent gene, all, because I think it is associated to to the genetic lineage. It's an structural gene of this genetic lineage that is the CC130. But I'm not completely sure about the difference in virulence of this. I have never detected, for example, PBL or TXT gene, the Panton-Valentine of the toxic shock syndrome toxin, in isolate that are MECSI. So normally are not especially virulent, but they always carry a specific virulent factor that is also a specific marker for detection of this isolate.
Okay. Probably my last question is, because you talk about in one study that you have got 18 different MRSA strain, in which 13 were MRSA, in which it is resistant, and 5 were MSSA, that is sensitive. And all these 18 MRSA and MSSA strains carrying the MAC-C gene, right? So
no, the susceptible didn't carry, but as the CC130 is always associated in methicillin-resistant with MECSI, I wanted to know if there were a specific marker of the CC130 that make more able to catch the MECSI that other genetic lineage.
Okay.
And in this sense, there were a specific similarity between, but we don't know yet why this MECSI is mostly associated to this specific lineage. But for example, CC130 had never been detected with MECA, always with MECSI.
Okay, so thank you very much. So I think Professor Raffaele is from University of Naples is here from Italy. I request if he can say something or comment or conclude the session. I give this opportunity to Professor Raffaele to please say a few words on the concluding session of this webinar. I think he's still on mute. Okay, I think he's not there. He's probably left. So with this, I think I conclude that the talk was very interesting, and we learned a lot of new things on MRSA, and especially with MAC-C, because in India, we don't find MAC-C yet. And maybe we can think of in future.
Yeah, but probably, sure, it's...
So, we can think of collaborating with your group, and
sure.
We can start screening on zoonotic background about this, some isolates, if they may have MAC-C, and I'm sure that they are, because the migratory, when you talk about the migratory birds, and these migratory birds are the major reservoir as well as the carrier of these markers all across the globe, regional as well as the different weather-based migration of these birds. So I mean, it might carry some time, and it might disseminate in Indian setting, and it may not be detected yet, but I'm sure we may have some way or the other way. So we'll see in the future some good collaboration with your group, and I hope all the best, and we'll be in touch with you soon. So with this, thank you very much for spending time with us, and see you again.
Thanks a lot to you and to all the people that have been participating in the webinar.
Sure.
Thanks a lot.
Okay.
Bye-bye.
Okay.